For t greater than or equal to 0, a particle is moving along a curve so that its position at time t is x of t, y of t. At time t equals 2, the particle is at position 1, 5. It is known that the derivative of x is this, and the derivative of y is sine squared. Is the horizontal movement of the particle to the left or to the right at time t equals 2? Explain your answer. Then we're going to find the slope of the path of the particle at t equals 2. Horizontal movement is x, and the y is the vertical movement. So we're going to evaluate dx dt, the velocity of x, at t equals 2. And if we plug 2 in for t here, we get square root of 4, which is 2. So 2 over e squared, which is greater than 0. That's going to be a positive value. The particle is moving to the right at time t equals 2 because the derivative of x is positive. Find the slope of the path of the particle at time t equals 2. We're going to plug 2 in for dy. So we get sine squared of where should I write that? Sine squared of 2 over, and then 2 over e squared. Over 2 over e squared. We're going to use a calculator, and we're going to get 3.055 or 3.054. No, I don't have to read the problem again. B, find the x-coordinate of the particle's position at time t equals 4. Well, we know the position is 1, 5 at 2. Now, if we knew the displacement from 2 to 4, we could add that to 1, the x-coordinate, and we get the value. And so we're going to use a calculator, and you get 1.253 or 1.252. For t greater, let's see. Find the speed of the particle at time t equals 4. Find the acceleration vector of the particle at time t equal 4. So the speed is the magnitude of the velocity vector. And if you use these right here, there's the velocity vector. That's the position. Here's the velocity. And if you do the magnitude on the velocity vector, you get speed. So we're going to plug 4 in. So we have the square root. It's really the square root of 6 over e to the 4th squared plus sine to the 4th of 4, square root of that. We're going to plug that in the calculator, get 0.575. Now, we can also use our calculator to find the derivative of these functions. That's math number 8. So math 8 gives us derivative. We're going to take the derivative at 4, and we get negative 0.041 and 0.989. Find the distance traveled by the particle from time t equal 2 to t equal 4. Well, distance along a parametric curve is the integral from 2 to 4, we're going from 2 to 4, of the square root of the derivative squared of x squared plus the derivative of y squared. And of course, we're going to use a calculator to do this. We get 0.651 or 0.650. And it looks suspiciously like the Pythagorean theorem. Here's the rubric, which I use the rubric to show you the answers. And the points were off to the side. Find the Maclaurin series for 3x cosine of x squared. Find the Maclaurin series for x squared e to the x squared. So that's two separate problems. So cosine of x is even. So we have the even powers, and remember it's alternating. And I forgot to write that here. So let's go -1 to the, let's see, if I'm starting at 0, I can do n. There we go, forgot that part. But then we plug, always replace first. Replace the x's with x squared, and so you get x to the 4th, x to the 8th, x to the 12th, and then multiply by 3x. So we distribute the 3x through 1, 5, 9, 13. The slope is 4. That's why we're going to get 4n. And then if I'm going to plug 0 into this, start at 0, I need to add 1 over 2n factorial. It's 0, 2, 4, 6. The factorials are even. Over here, e to the x is 1 plus x squared over 2 factorial, x to the 3rd over 3 factorial, because the derivative of e to the x is e to the x, and e to the 0 is always 1. Now we're going to replace x with x squared, and we get 2, 4, 6, keep on going, so we have the even powers of x, and then distribute x through, we get 2, 4, 6, 8. So that's x is 2n to the 2n plus 2 if we start with 0, and then we have n factorial in the denominator. Here is u substitution. We're going to let u equal x squared plus 1. This is an improper integral, by the way. So we have limit as a approaches infinity from 1 to a now. This is u substitution. We have 1 over u squared. The integral of 1 over u squared is negative 1 over u. So negative 1 over u. And so that's negative 1 over u is x squared plus 1. Well, that's good news for convergence because now the variable is in the denominator. And we're going to go from 1 to a. So it looks like, I put that in. Let's fix this in real time. Shame on me. Let's fix this. See if I can get this right this time. Let's limit a approaches infinity of, we're going to plug in a first, negative 1 over, did I have that? Maybe I already had that. Plus 1/2. We're going to plug infinity in here. We're going to get 0. That's going to be 1/2. I think I had that right in the first place. Find all points of inflection for 4x to the third minus 12x squared. Here's the first derivative, second derivative, set equal to 0. X is 1 is a potential point of inflection. If we plug 0 in for the second derivative, we get negative 24. If we plug 2 in, we get 24. So there is a point of inflection at the point 1, negative 8. We plug 1 in, we get 4 minus 12, that's negative 8. Find the interval of convergence. We're going to do the ratio test on this. Here's the ratio test with the n plus 1 divided by the nth, or multiplied by the reciprocal. The limit on the n here is 1, so we get 3x minus 2. Now 3x minus 2 needs to be less than 1. So we have negative 1 to 1, add 2, that's 1 to 3. Divide by 3, we get 1/3 to 1. Now, one of these makes this negative 1, and the other one's going to make this 1. Now, when that happens, let's see. Well, no, we're going to check 1/3. 1/3 of 3 is 1 minus 2 is negative 1. So this converges by alternating harmonic series. When we plug 1 in, we get 3 minus 2. That's 1 to the n, which is just 1. So this diverges by harmonic series. And the interval of convergence, that's wrong. I need to be a little bit more careful when I write these out. The interval of convergence, see, good at 1/3, 1/3, bad at 1. There we go. What is the What is the particular solutions to the differential equation with the initial condition y of 1 is 0.25? Well, let's split the differentials. So I pulled y squared over here. That's in the denominator. And multiplied by dx. So I left the negative 2 with the x. The integral of 1 over y squared is negative 1 over y. Integral of negative 2x is negative x squared plus c. Plug in the points. That's negative 4 is negative 1 plus c. So c is negative 3. So we went to this spot right here. Negative 1 over y is negative x squared minus 3. There I plugged the negative 3 in. Multiply everything by a negative and then take the reciprocal of both sides. Or you can really think of it as cross multiplying. You get the same thing. Find the slope of the rose curve r equals 2 sine theta at the point where theta is pi over 6 and use it to find the equation of the tangent line. So x is r cosine, which is 2 sine 3 theta, cosine theta, because here's r right here, 2 sine 3 theta. So there's the r cosine, here's the r sine. Now dy over dx is first times derivative of second plus second times derivative of first. Dx is the same thing. When we evaluate at pi over 6, we end up with negative square root of 3. Well, we need the point. We need x of pi over 6. That's square root of 3. Y of pi over 6 is 1. And then here's the equation of the tangent line. Y minus y1 equals the slope times x minus x1. What are the first three partial sums of s sub n equals negative 2 to the n? So if we plug 1 in, we get negative 2. There's the first partial sum. Plug 2 in, we get 4. Negative 2 squared is 4. So the second partial sum ends up being 2. And then the third partial sum, negative 2 to the third is negative 8. We take the previous, add negative 8, and we get negative 6. Here is partial fractions, and here's the answer. Down here, we've done partial fractions several times. If you have questions on this process, don't hesitate to shoot me an email. But I'll just show you the work here, and that should be, I think that should be good. And if it's not, let me know. Use a right-Riemann sum to estimate the sum of the following with 4 subintervals of equal length. So the graph is x squared, four subintervals of equal length. Well, if you cut 2 into 4 pieces, they're all halves. Here is a right Riemann sum where the right side of the rectangle hits the curve. Now, all of the bases are a half. So we have a half times. 1 half squared is 1/4, 1 squared is 1, 3 halves squared is 9/4, and 2 squared is 4. So if we add these up, we get 30/4. 30 divided by 2 is 15, 15/4.